And it's my honor and privilege to introduce to you this afternoon Professor Dana Buntrock, whose lecture will be followed by an opening of the exhibition Seiza Sana upstairs immediately afterwards. There's a lot to say about Dana. I hope at the risk of not embarrassing her, not the least of which is her generosity of spirit. And I owe quite a lot to her myself from my first trip to Japan, when she opened tons of doors for me, arranging me to meet people, to visit buildings, and even helping me line up accommodations. And I'm not the only person who's been the benefactress of benefactee. That's it. Even this past summer, Dana and I went to the shrines at Ise together, and we were able to visit an amazing new project of Sana in Tsuruoka, the cultural center, which is just nearing completion. You could say that a motto for Dana is Dana opens doors. You like that? This has intellectual registers as well. She studied architecture at Tulane and then at Michigan. She's taught at Carnegie Mellon and IIT, has done a number of postdocs and prestigious fellowships in Japan at various universities there. And for the past several years, she's been at UC Berkeley, where she's become full professor, and she also chairs the Center for Japanese Studies. In her first book, Japanese Architecture is a Collaborative Process, Opportunities in a Flexible Construction Culture. That book was a bit of a groundbreaking account of contemporary construction in Japan, and it involved countless hours that she spent on job sites of important buildings as they were being constructed around Japan, hours that she spent watching and documenting the process, talking to architects, but not just architects, also the contractors, the subs, the producers of various materials that were involved, et cetera, et cetera. And you could say that she knows design and construction both from the ground up, and that she knows it from diverse cultural perspectives. And it's no wonder that the construction courses that she teaches at Berkeley are enormously popular. Even better, she gets the students out in the field on job sites where their project is to study a project under construction, and they get to document it, interview people, learn firsthand what's involved in that whole process. She's also currently working in the energy industry and energy use in contemporary Japanese architecture. And her talk this afternoon is related perhaps more to that, called What Could Go Wrong. And I think it's extremely timely that today marks the 100-year anniversary of the great Boston Molasses Massacre, where something very much went wrong.
Okay, no, I got this.
Oh, you have that. Okay.
One of the things that's interesting about this building is that it could have happened at any time in Ando's work. You don't look at Ando's work and see any kind of a clear evolution, except for an evolution in scale and location. As he got more and more famous, he worked more and more abroad. His buildings got bigger and bigger and more complex. But in a lot of ways, the moves are pretty straightforward, and he's playing the same game. He plays it well and in interesting ways. Now, I'm not the only one who likes this building. It's kind of interesting. Ando must like it himself because he did it twice, which is pretty unusual for an architect, right? The client won a competition. He had a very difficult construction site, and one of the Japanese magazines had a competition. Name an architect that you want to work with, a really weird site that you have a problem with, and we'll try and get that architect to build your building. And the owner was a guy who worked for a construction company, and the site, it's probably easier, I think they photoshopped out all the wires, I'll show you in a minute, is right on the edge of the inland sea. And the building itself has some things that make it fairly complicated. It's a 4-story tower that lands on a very small footprint, so it was pretty expensive. When it was built in 2003, it cost over $300,000. And so it came to about $240 a square foot. Now, you'll hear that Japanese construction is more expensive, and that's true both because of the craft and because of the earthquake issues. But 60% higher than normative construction is still expensive. And the guy actually, because he worked for a construction company, was getting a deal. This would have been an even more expensive building if he had done it and he didn't have those connections. And he was interviewed in the New York Times about the building, And one of the great quotes was, he said, "My wife often complains about the ups and downs involved, especially when she has to bring groceries up to the kitchen after shopping. Because the kitchen's on the 4th floor and it's only stairs, no elevator," okay? I'm kind of, now that I've been thinking about this building in terms of talking to you guys, I think I'm gonna go back and see if they're still living in it, because they're a little older than me and I'm wondering what's happening to their knees, you know? The body of the water that this building faces, the inland sea, is salty. And Ando put a little tiny hatch up on the roof, and I'm going to show you that building again, that allows the owner to get out on the building and try and spray water on the outside to spray the salt off the building. Because nobody does power washing in Japan. And you know, I don't think it works. Let's just say that. So let's agree that this particular building isn't very practical, but that doesn't mean we can't love it, right? It's poetic. That's one of the attractions of Japanese architecture within our community. You know, Mark mentioned, and incidentally, I should say, one of the things I love about dealing with both Mark and Saber is the way that they integrate really rich discourse about buildings. When I deal with them, they're like me. They want to get down there and look at the nuts and bolts and things like that. And that's really rare for design faculty. I think it's much more common for the faculty like myself that teach technical topics to want to engage with both the design and the technology. Design faculty often act like technology is something that you can kind of add on later after you've done the diagrams. That may be different here, but that's my general impression with a lot of schools. This is a test question that another colleague of ours at Idaho did several years, a couple years or a year after the building was completed, 2005, where he was asking about how you would handle some of the water issues on this building. And remember, you're supposed to be able to climb up there and wash the front of this building, right? To get the salt off. So, I mean, the water issues in general, let's just start by assuming that they're not a really conducive part of this whole discussion. For me, as somebody who cares about whole buildings, as somebody who was licensed for about 25 years until I got tired of paying the extra money, I think that architecture should be something that has both a pragmatic and a poetic side. I think that we can't have one or the other. And so I think of it as bread and roses, okay? And on the side of the roses, right, that's the whole sort of Vitruvian, what you call Venustus. The beautiful things about the building. So with this Ando building, you know, a little tower at the end of the inland sea. That really sounds like a kind of a piece of poetry right there, right? I want to live in a little tower on the edge of the inland sea. It has an overlarge window. It has a big, tall space. The guy says living in it is like living on a ship, right? And you can imagine that. Also, if you look more closely at it, you'll see that it's got a really solid base and that it opens up more and more as you get higher, which is another kind of a poetic gesture. And the building has this wonderful sense of both a symmetrical part and an asymmetrical part in balance. And then the bigger game of the two buildings playing with another level of symmetry. So that's the roses part. But I teach construction. I think all the pragmatic stuff is important too, the bread, the meat of the stuff. And, you know, if we talk about it again in Vitruvian terms, we would talk about firmitas and commoditas, right? Easy to use, not working out so well for Ando. Understanding costs and construction. Well, he understands costs and construction. He just wasn't too worried about it. Plausible approaches to maintenance and durability. This seems to be one of the things driving Sabra these days. Very exciting. Not a lot of people thinking about it, but, you know, like our governor, just one of the first things he did in the State of the Union address this year was to say he's going to give our university money for deferred maintenance. And every professor in this room is thinking, hallelujah. So, you know, really important if you own a building. And then keeping structures safe, making them perform well, that kind of thing. One of the things that's interesting about looking at Japanese architects versus looking at architects in a lot of places in the US is that they invert which one they're going to compromise on. So when we make compromises, we compromise on the poetry of the building in favor of the pragmatics. That's a very typical thing. The US is driven by strong economic interests, so that makes sense. In Japan, especially in the circles where architects you know of operate, very often the thing that gets compromised is the pragmatic side in favor of the poetic side. So it's a sort of a reverse. And why do they do that? And the answer is prizes, okay? If you do this, you really stand out. You get picked up in the media. People go to your lectures. You know, you go to a Tadao lecture, 800 people line up. They wait for hours to get in because they're very excited, because they understand the poetry of buildings. A lot of the kind of lay people that get excited about architecture get the simplicity of these buildings, and they recognize why they're different and exciting. And it's not just Ando. So in the case of the Pritzker Prize, you can see that there are a number of other people working in this vein who, again, have won this prize. In fact, if you look at, I'm going to move this over so I can keep doing this. You look at who's won Pritzker Prizes. 7 people from Japan, one of whom's operating out of Paris, have won the Pritzker Prize. Only 5 people born in the US have also received Pritzker Prizes. Japan has a third of our population, so they're much more successful on this particular score. And even if you're looking at immigrants, there's only 9 US-based firms that have won Pritzker Prizes, including people like the Canadian Frank Gehry. And, you know, there's 6 people that are living and working in Japan that have won Pritzker Prizes. So, you know, the poetry has a real benefit for architects that's worth paying attention to. On the other hand, the problem is that the reason we get hired, the reason our clients ask us to do things, is not for the roses necessarily, but for the bread, right? Their decision about the value we bring to them is based on that. And so one of the problems is that if you look at Japanese architects, you can see, first off, they're really poorly paid, okay? So this is from a few years ago, I think it's 2013. And the average salary is about $48,000 a year. And this is for people who are like 49 years old and have about 16 years of experience. And if I told you that you're going into a field where you're going to get paid like that, you probably would not be very excited. The good news is in Georgia, it's almost double that. This is exactly at the same time. So you can see this little guy over here. I have to actually read it here. 80,000 to 93,000, right? Roughly double the salary for an architect working in Georgia versus an architect working in Japan. That's a big difference, right? And it says a lot about social value. Some of you have visited Japan, or you've looked in the magazines, or you've thought about going there as an intern. And one of the things you might also notice is that the offices look like this. They look like, your studios actually are very nice. Do they look like that all the time? No? Okay, it's just because it's the beginning of the semester. They're really nice. They're clean. You have lots of space. This is Kazuyo Sejima Ryue Nishizawa's office, okay? And I kind of panicked. See all the paper? There's no insulation in this building, and so everybody's got those little heaters under their desks, and they have all this paper. And the corridor from where Sejima sits to the front corridor is defined by these bookcases, which if you're running through, I think you're going to knock down all the bookcases. And I'm always afraid in the wintertime they're going to burn themselves down. And I've told Sejima-san that. If I try and call the office, I never think about what time it is if I'm calling Sejima's office, because there's always somebody there. 3 in the morning, there's somebody there. And they don't have the economic infrastructure for the secretary and the other kinds of people that you're used to here. It's a very, very limited funding context for the studio. And so that's kind of an important thing to think about. Now, if I go back to the Tadao Ando building, this is a guy at what's called Fukushima Daiichi, a couple of nuclear power plants that melted down in 2011. Now, most of you guys are in your 20s, right? So you probably don't even remember this, but in March of 2011, there was a couple of big earthquakes that happened pretty much concurrently. And so they registered about 7.9 on the magnitude scale, which, just let's say, it's a really big earthquake. It's not the biggest earthquake we've ever heard of, but it's a really big earthquake. There was a big wave called a tsunami that washed the entire eastern shore of the northern half of Japan, and about 20,000 people just disappeared. They were just washed out to sea. Well, one of the things was that in the 1970s, when people were building nuclear power plants, they needed some way to cool them. And one thing that looked like a good idea at the time was to put the nuclear power plants down right against the ocean, because then what you could do is you could take this cold water from the ocean and you could cycle it through the nuclear power plant and you could cool it. Doesn't that sound like a great idea? The problem is when you have a giant wave that washes up onto a nuclear power plant, it shuts down all the backup systems. And that's why they had 2 meltdowns. They were actually really lucky. It could have been a lot worse. So what does Tadao Ando's building have to do with a nuclear power plant? Well, here's a section of Tadao Ando's building. So here's the living space up above with the kitchen that the wife carries her groceries up to on the 4th floor. This pink line is the only insulation in the building. Okay? So it's solid concrete walls. You guys know it doesn't have to be, but it is. There is actually double glazing on that big, tall window, but the double glazing is in a steel frame that probably doesn't have a thermal break. There's a guy here from YKK who knows more about whether it does or doesn't, but let's just say 99 times out of 100 in a building from this period, no thermal break. And I'll show you some other examples. The windows are fixed. They're not operable. You can't open them. And so what are you going to do to be comfortable? Well, the insulation's actually there to keep the hot water pipes hot. See, you can see it's between an interior space and an interior space. But what they're trying to do is they're trying to make sure that the floors, where they're walking around either in slippers or in their stocking feet, aren't cold. And they thought that the best way to do this was to put the insulation right there where those hot water pipes are. Now, for anybody in this room who's my age or older, these kinds of buildings are not surprising. This one's in Tokyo. It's more recent. Infrared technology allows us to take pictures of it. But if you look at buildings from the 60s or 70s in the United States, you'll notice that a lot of the action at the envelope was about dealing with this problem. You have a lot of humidity inside the building. You don't have any kind of thermal barrier between the inside and the outside. The surface gets cold, you get condensation. Okay? And this was Dow Chemical's offices. So they said, we didn't clean it up this morning because we thought you'd like the picture, because they knew me. And this is how much water had collected overnight on their windowsills from the condensation. So if I'm talking to anybody I know in Japan, they're very familiar with this problem, which creates a lot of other problems. Tadao Ando's buildings sometimes have sick building syndrome because that condensation is captured inside the building and it can promote fungus and mold, right? So that's a big problem too. So this kind of thing is, like I say, not uncommon. We used to have it too. We dealt with it in the 70s. Japan can eventually do the same. Now, Mark and Saber, when I was telling them about this last night, they said, but maybe Kobe's climate is so benign that they don't need insulation. And I actually don't think there's many places in the planet where that's true, but you'll be happy to know it's not true here. Here's Atlanta, here's Kobe, okay? Pretty much the same latitude. And in fact, if you look up the climate data, here's Kobe's climate, here's Georgia's climate. You guys get a little colder, as we might be noticing right now, right? And your summer is longer. But interesting, the maximum highs and lows are very similar, right? And so this climate is the environment in which this large, concrete, uninsulated building exists. Now, is Tadao Ando a bad architect? No, he's operating in a different environment. He's operating in an environment where insulation is not the norm. And so here you can see, this is in 2014, so this is after the meltdowns and everything. And this is all buildings. So if we go out into Georgia, some of the buildings you're going to see were built in the 1950s or the 1940s or something like that. And if nobody's done any energy retrofits on them, they're probably not insulated either. But these buildings don't meet Japan's building standards, and the standards are pretty benign, okay? So the 1999 standard assumes that you're going to have about 4 inches of insulation in the walls and about 7 inches of insulation in the roof. And only 5% of the buildings in 2014 complied with the 1999 standards, right? And 40% of them had no insulation. So is Tadao Ando a bad architect? No. Is Sejima a bad architect? I'm going to show you a Sejima building with minimum insulation? No. They're good architects. They're working in an environment where people didn't think much about this. The solution was to add heat. So if you talk to your parents, or maybe if you guys are your grandparents, if they go back far enough, like this old dude he sent his hot plate in for repair once in '68. Notice what he's doing. He's got this raggedy looking coffee pot that's sitting there, and he's just going to drink hot coffee because it's going to sit there and keep absorbing heat all day long. Now, most of you, I hope, have never drunk coffee like this, but if you do, you'll discover it's not great coffee. We don't do this anymore, right? We figured out that you can insulate the coffee cup and you can actually get better coffee, right? There you go, Georgia Tech, I even found you guys. All right, so why doesn't Japan, incidentally, those standards I showed you, those aren't mandatory. So why doesn't Japan have mandatory requirements that you insulate buildings? And one of the answers has to do with going back to the oil shock when we all started thinking about this. So in 1973, when we had the first oil shock, one of the things was that buildings used a very small slice of total energy consumption. Manufacturing, including making steel and concrete, which are very, very energy-intensive industries, used a lot of energy, and transportation used a fairly small slice. But once you started to do this, change the dynamics for how manufacturing used energy, it was also easy to change things like the design of cars and trains. So these two were able to be easily addressed. And Japan put all its energy into pulling back all its energy, that's a joke, used all its effort into pulling back how much energy was going to be consumed in industrial production rather than in buildings. For the US at that time, this piece was much bigger. We had to deal with it. And so we actually got in front of dealing with energy consumption in buildings as well. So what happened? This, as you can see, everything stayed pretty flat along this period after 1973 because people were very intensively trying to save their own country's economy by reducing energy demand. All the energy came from outside. Japan's energy self-sustainability ratings are about 4%. Okay, that means 96% of the energy they were using was coming from outside Japan. And so they had to figure out a way to deal with the fact that OPEC was making their energy expensive until OPEC collapsed. And then you can see what starts to happen. It's like, da, 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 happy days are here again. And everybody starts using more energy. Now, these guys don't go up much. Why not? Because in the manufacturing processes, they put in new plants and new equipment, and now they're invested in the new plants and new equipment. And so it's not going to climb as fast. Even though their production's going up, the manufacturing systems are already in place. And you can see transport goes up some, but if you actually look at it in terms of miles traveled or something like that, you'll find it doesn't go up very much. But what goes up is buildings. Okay, so manufacturing, the energy actually comes down from 73. Transportation, it goes up some, but the miles traveled goes up a lot. Buildings, residential buildings, 2 times as much energy, and commercial buildings almost 3 times as much energy. So now you're starting to see that the kind of cavalier way that people dealt with energy in terms of the regulations back in the 70s have implications. So this is Kazuyo Sejima's house. This is where she lives when she's in Tokyo. And one of the reasons I put it up is I wanted to point out that there's another thing going on as well, which is that the architects are thinking of it not as a building which has to survive cold, but as a building which in a kind of old school way can keep you comfortable when it's hot. So this picture, there's this bench, and it's right there. And there's this giant window that brings air in, and there's a roof piece here where almost the whole roof opens up and allows the air to go out. And so this is really kind of a shady outdoor space where she can entertain friends and she can sleep and all that kind of thing. So that's not bad. Well, as long as it's summertime. Now, I'll tell you a funny story about this house. Sejima moved in February, and I happened to be living in Japan at that time. And so I went over and I said to her, hey, congratulations, new house, right? I brought flowers, all that kind of stuff you would do. And we sat down and I said, how do you like the house? And she said, it's very cold. It was a pretty cold winter that year. And all of this, right? Concrete floor, no insulation. You can see the roof, no insulation. Walls, no insulation. And all the heat was up there, and Sejima was down here, right? And she was like, I am really unhappy. I'm really cold. I'm going to go on an international trip, and I'll figure out what to do. And when summer came around, they decided that the best solution was, now if it was here, we'd say insulate, right? But that's not what she decided to do. They tore up this concrete floor, and they put in a heated floor, okay? So that she would be more comfortable and there'd be more heat radiating from the floor since that's where she was. For anybody who's studied energy issues, this seems very counterintuitive. But what you guys have to understand is the whole discussion we've had about hot air being up in the ceiling and all that kind of stuff, that comes from more than 40 years of awareness of the way we need to conserve energy in buildings. And it's become very commonplace to understand it. It's talked about in the newspapers, it's on the television. These kinds of discussions right now aren't happening in Japan because there hasn't been a sense of urgency about doing this. Okay, so what happens is that energy becomes a kind of a luxury. Especially electricity is seen as a luxury in Japan. This is a new art exhibition. It's 100,000 square feet of immersive technology that just opened up last summer in Odaiba, which is a recreational area of Tokyo. It's by an artist group called Team Lab, and the thing is called Borderless. It has 500 servers. It has 470 high-power projectors. It has a bunch of human load in it because everybody wants to be there. And all this heat's being dealt with by air cooling systems, not by any kind of insulation. It's very cool. If you go, you have to go see it because it's like, being on the safest LSD trip you could ever be on, right? I mean, it's just this amazing thing. You walk out and your brain is deformed for about an hour. But this is not what I would have anticipated as the next major art movement in Japan only a few years after it had nuclear meltdowns, right? It's a very strange direction for industry to go. Now, you've seen examples of this. Even if you've never been to Odaiba, every time you look at an expensive neighborhood in Japan, you see the way light is used as a kind of projection of luxury. And so this is in Ginza, which is a very expensive area to go shopping in. And you can see there's a lot of ornamental illumination. And then there's also large areas of glass where there's a connection between inside and outside, a lot of this single pane glazing. And there's very limited use of daylighting beyond the kind of periphery. If you go into these buildings, you'll see pretty quickly the electrical light takes over. And the electrical light may do exotic things. It may change colors. It may have displays. There's all kinds of ways that there's an expression of the kind of excitement that electric light suggests. So by now, I hope you're starting to ask yourself, what does this really mean for us as architects? And one of the things I keep saying to people is, if electricity is the problem, and it is in Japan, then we're the solution. We as architects are the solution. Because somewhere between 60 and 70% of electricity in any developed country is used in commercial and residential buildings, okay? And some of that is your little computer and your phone and that kind of thing. But a lot of it is the lights and the heat and the refrigerator and all that stuff. And so if we figure out how to conserve electricity, then that's going to play out in really powerful ways in our countries. So I don't know if it's ever occurred to ask yourself, how did we get in this mess in the first place? But the answer is, everybody thought atomic power was the kind of magic bullet for everybody, right? So Gene Seaborg is a guy that was trained at Berkeley in the 30s. He was a professor and an assistant chancellor and stuff at Berkeley, very influential guy. And he said that atomic power will make electricity too cheap to meter. I'm sure you've heard that. Is your electricity in your house too cheap to meter? No, yeah, mine either. Okay, so, but there are some really interesting connections between electricity and nuclear power in Japan and architecture. Why is this? There we go. Okay. So I don't know if you know Ryuei Nishizawa's work. Nishizawa did this separate from Sejima-san. Sana is their joint practice, and they each have their own individual practices as well. And this is an art museum called Arts Towada. Okay, it's up in northern Japan. And you know, if you read about this normally, this one's from 2008, you're going to see something like this. So this is from an art magazine. I can't read it from here to tell you which one. And this is what the author said, based on what Nishizawa told him. In a conservative city such as Towada, and it's a bunch of old farmers, where the lifestyle seems not to have changed for 50 years, the opening of a contemporary art center was not a project welcomed by all. Now, this cosmopolitan journalist says, why would you not want this fabulous Nishizawa building in your midst? You must be rubes, okay? They're not rubes. They're just fiscally concerned, okay? So here's the total operating cost for the building, $1.1 million. It's a town of 65,000. So I did the math. It's going to cost you $17.60 a person to operate the building every year, okay? They get a certain amount of it. Oh, you need to see it up there. They get a certain amount of it from the national government and from what's their version of the state, what's called the prefecture, but they pay a lot of it themselves, okay? So they didn't want to pay for operating this expensive building. And why was it expensive? Well, it's in a cold place, okay? The average temperature in January is about what it is, or what it's going to be here in the next few days. It snows a lot. And this is the building plan, okay? And I don't know if you noticed, but every single exhibition space is a separate and isolated room. And also, all of these are single-pane glazing. And again, no thermal breaks in the framing, all right? So one possible reason, I don't have the budget information for the high operating costs, is probably keeping it comfortable for the little old ladies and little old guys. So I said I was going to connect this to nuclear power. One of the things that's really interesting is the more electricity you use in Japan, the more money there is for nuclear power. Because there's a hidden subsidy in everybody's bill. And that subsidy yields, it's about $2 a household a month, okay? Not a lot of money, but you don't see it on your bill. You can go through your bill, and I put a bunch of stuff up there, and you won't see anything that says nuclear subsidy. Interestingly enough, more recently, there was a desire to start to also subsidize renewables, and you can see the 6 cents involved for the renewables on your bill, okay? So they collect this money for the nuclear industry, and what do they use it for? They use it for promotion, for getting local communities to be excited about having nuclear power in their community. So if you've been to Japan or you've looked at the magazines and you thought, wow, this is a town of 65,000, it's a bunch of old people, what are they doing hiring Nishizawa, and why doesn't my town of 60,000 hire Nishizawa? The answer is your town isn't getting subsidized to take Nishizawa, and that town did. And so altogether, there was about, this is about, let's see, 20 20 billion yen, or $20 billion in subsidies that were used for promotion for different kinds of nuclear development. And of that, about 6 billion for promotion. And it went for schools and cultural centers and recreational facilities and roads and all kinds of stuff like that. And after the nuclear power plants melted down, one of the things I did was I started digging around a bunch of information, just kind of randomly, like you might do, trying to figure out, is there nuclear money in any of the buildings that I've been looking at? And I was able to find some, like Towada. So this is actually funds for Towada City. It comes from the Rokasho nuclear fuel plutonium reprocessing plant, and also some large hydro plants. Okay? And that year they got 20 million yen, which sounds like a lot, but we can go through each year, we can start to look at it, and we can add it up. And it only adds up to about $1.3 million over 5 years. Remember, it costs almost $1.2 million to operate this building for a year, and you can only get these subsidies for 5 years. So they're actually not coming out ahead by buying into this deal, right? And you can see examples of this all over Japan. All right, so this guy's pointing at Fukushima Daiichi. And one of the things that's probably occurred to you by now is architects as a group are incredibly idealistic people, right? We all want to have positive change in the world we live in. So when these nuclear power plants came down, what did my community do? What did architects do? And they did what they could. They put a lot of energy and a lot of their own money into doing things. But you'll notice a thread, which I'll talk about in a minute. So one guy organized a kind of Tour de France in Sanriku, up near Rikuzen Takata and stuff, where they had these people doing bicycle races through the communities, kind of bring excitement to the community, bring some money, that sort of thing. Kengo Kuma, who you probably know about, proposed a new museum built of rubble. That didn't go over so well, as you can imagine. Ito Toyo got some young architects together to design a community center in Rikuzen Takata, and they also raised all the money for it themselves, which sounds really great, except I have to tell you, 60% of the population of this town is over 65. And I mentioned earlier about knees. I actually met the mayor of this town, and he said, this building got the Golden Lion at the Venice Biennale, and that makes no sense to me because most of my local community can't get beyond this room, right? Why are you people giving awards to this building? I went around and I talked to some other people at some of these buildings. All of these are funded through Home for All. They're funded, I donated $10,000. Some of your professors probably donated money. People really tried to kind of support the citizens of Japan. So this is another community center that's built. There's a lot of little temporary buildings for little old ladies because they lost their houses. And this is where they can hang out. So I went in and I was hanging out with them. And I noticed this. So there was this, I've got a lot more images of this, but I'm only going to show you a couple. There was a concrete floor, as you saw. There was a membrane roof. It's a cold part of town, of the country. And so we're sitting under there, and I realized they had an electric heater underneath the table. This is not uncommon. It's called a kotatsu. But I was also pretty comfortable. And then I saw, oh, there's some insulation and some metal that's taped to the floor. And they said, we did that. You know, they did it themselves because their feet were cold and their legs were cold and they weren't using the building. So they went ahead and they did it. And you can see the way that plays out. So the area under the table is kind of warm. The minute you get away from that area that they laid the insulation and the metal on, now it's back to being really cold, okay? So kind of limited use beyond that. Another group, which I'm very fond of, ArchiAid, raised about $500,000 internationally. 300 architecture students and faculty from around the world went and worked and got involved in projects. Another 200 students in Japan. They did a lot of workshops. This is one of the architectural teams. These two are professors in Tokyo. They're friends of mine. And these are their clients. And these are fishermen, okay? They're really, well, they're retired fishermen. They're now in their 80s. Little old lady, he's actually married to another woman who's disabled. I think he's actually a friend or something. He wasn't in one of the buildings. And they made these 3 buildings that replaced the homes that these people had lost. And you'll notice that the buildings try and be really sympathetic to the vernacular expectations of the community. That was a big discussion among Arcade. How do we actually deal with the fact that the people that we're building for don't want big fancy architecture? So they said, okay, we're going to do this. We're going to go ahead and we're going to make them with tile roofs and that sort of thing. Well, they started to realize they wanted to save energy in these buildings. And so those 2 architects came over to California and they met with a bunch of my colleagues because there's no infrastructure for finding engineers who can help you figure out how to save energy through passive systems in your buildings. If there's no demand for it, then the contractors and the engineers and that kind of thing aren't going to learn how to do it. So you had to go elsewhere. So these architects came over to California, and some friends of mine, who I'll show you in a little bit, went ahead and advised them about how to design this building. They talked about vapor barriers and about creating locations where you were going to have cold air seeping in and change the performance. And they showed them how to use infrared cameras during construction to create a safer and more comfortable environment. Well, there was a problem. So this is that little old lady's house. I went to visit her. And one of the things you might notice is here's a kerosene heater. A lot of the people in the country use kerosene. And I'm pretty sure none of you have ever been in a space where kerosene was the primary heat. Well, sabr when you were a kid, right? But fundamentally, this is not a very healthy way to do things. The exhaust from kerosene burning is bad for your health. Now, this little old lady said, I'm in my 80s. I don't really care. I'm going to go ahead and burn my kerosene heater. And so all the people in the city got really upset. What are we going to do? Because we don't want to be responsible for shortening her life. And so they decided what they were going to do was they were going to basically vandalize the high-performance windows and doors. So that what would happen is you'd get a lot of cold air that would be drawn in through these windows and doors and create natural air movement. And for those of us who are older, you can kind of remember when there was talk about what do we do if the building doesn't breathe, right? This was a conversation we had 40 years ago. So they damaged the weather stripping and stuff. And now the little old lady's really happy because she operates her kerosene heater. Plus she figures she pulled a fast one on the flashy architects from Tokyo. The other thing that I noticed, though, was that the other clients, they had these kind of air conditioner, heat pump type units, like you have some around here, that they could turn it on as an air conditioner, a heater. They had a remote for it. And they said to me, we've ended up using kerosene too. And I was like, why are you doing that? And they said, well, we can't ever figure out which remote is the right one, right? And I pointed at this one and I turn on the heat 2 rooms over. And that's not what I want. And then I have to read it, and I don't know where my glasses are. And the system actually was too hard for them to use. And so even though some of these buildings could have made really persuasive arguments for high-performance architecture in these little communities, the fact that they were incompatible with people's understandings about how to use buildings became a problem. All right, so Arcade was working all over Tohoku. They were trying their best. In truth, they only built on about 30 sites. They did some other stuff, but fundamentally, if most of them look back, they say, we put a lot of effort into it, and we're not sure how much we accomplished. Meanwhile, the Japanese people were much more effective and have been much more effective. They were going crazy, because they suddenly realized if a nuclear power plant melted down in their community, the government wasn't planning on doing a lot to help them. And so the Japanese people were literally out demonstrating, which is very unusual in Japan. And as a result, Japan has closed down a certain number of its nuclear power plants. Each one of these represents a reactor. Now you might think, wow, That's a lot of nuclear reactors for a little tiny island. First off, remember, it's a little tiny island. It's not connected to the grid. It doesn't have any electricity supply coming from someplace else. In Georgia, you can get electricity from Alabama or New York or New Jersey or wherever, Tennessee, and you're fine. But these guys, all the energy has to be produced in Japan. They had 54 nuclear power plants on the day of Fukushima Daiichi's meltdown. They had 1/10 of all the nuclear power plants in the world in Japan. Pretty dramatic, huh? So this is where the meltdowns occurred. They said, "Nyap, nyap." And the nearby went to, "Nyap, we're done," right? Okay, a couple other ones that kind of figured out, hey, maybe this is not a good idea. They're pretty old. And so they shut down about 19 plants. They have 9 plants operating now. They opened a couple more in November. 6 have been approved, but they're not operating because of public voice, okay? People are too hostile to nuclear power. 12 more are seeking approval, and 9, these little gray ones, it's the industry trying to figure out how far can we get, right? If they can't get these approved, they're going to give up on these. If they get these approved, they're going to try and get those other 9 into the queue. So there's still a big question about what Japan's energy performance practices are going to look like. And by the way, here's Ohi, so it's down here on western Japan, kind of just above Kyoto. The other thing that they started to discover is that under these nuclear power plants are fault lines. And you guys don't live in a seismic area, but I do. The reason we had an earthquake this morning was that we have a fault line that runs actually about 100 feet from the building I teach in, okay? And when you have a fault line, what happens is the Earth can either move this way or it might move this way. And a lot of these nuclear power plants turn out to be on fault lines. That's nobody's fault, not to use another pun. The reason for that is that seismic engineering is only about 120 years old. So when they built these things in the 70s, which is 50 years ago, seismic engineering was a lot more rudimentary than it is now. And they only decided that there were plates and fault lines in the 1960s. So they didn't even know to look for this stuff. When they first started talking about plate technology, it was incredibly controversial. So they started building the nuclear power plants not knowing how this was going to play out. Okay, so one of the things I hope you've been curious about is, did demand for energy drop in Japan after these meltdowns? And the answer is kind of, right? Kind of. And nuclear power dropped a lot, but Japan got a great idea, which is not unusual. Not to reduce demand, but to increase supply elsewhere. And where did they increase supply? Coal and gas. Japan is the only developed country in the world right now that is building coal plants. Yeah, I figured you guys would love that one. So here it is. Coal right now, well, 2 years ago, was supplying 1/3 of Japan's electricity. It's up, okay? And furthermore, there have been some articles on it, why Japan finds coal hard to quit. Let's look at these numbers. Coal's share of Japanese electrical power is expected to increase to 46% by 2030 if they can restart more nuclear plants. And if they can't, 56%. Now, I don't need to tell you about climate change. You guys all know, because this is the challenge for your generation, okay? In Japan, it should be as well. Most of Japan's major cities are along its shores. So if they see sea level rise and they see nastier storms, it hits them where everybody lives, okay? And increasing coal production is probably not the right solution. I'm not going to go into it in great depth, but one of the reasons that coal and nuclear power are so entrenched is that they are highly valued by the business and political communities. Okay? And we, as architects, are not. Our voice is not at the table in terms of a solution for what to do about nuclear power in Japan. And that's a pretty serious thing. So you might be wondering by now, I got a lot of friends in Japan, and there was this nuclear meltdown, and what was I doing? So I'm going to tell you a little bit about a few things I've been doing. I was actually I was scheduled for a panel a week after the nuclear meltdowns, and they went, oh, we have to reorganize this, and they got rid of everybody else on the panel and just filled it with nuclear engineers. And just take my word for it, you don't want to be in a room with a bunch of nuclear engineers after a meltdown because they're telling jokes, okay? And the people on this side, they were people who were from Japan who, freaking out, had actually fled to Berkeley by airplane and wanted to know what was going on because they thought we would give them better answers. So I got hit right in the face with the nuclear power thing. One of my old professors was there, and one of the things he said was, hey, Dana, what about the kind of break line between electrical supply in southern Japan and northern Japan? And I'm like, what are you talking about? And he explained to me that there are very few transmission connections between the two parts of Japan. And so all the nuclear power plants that were in the southern part of Japan would not be able to make up for the lost supply in northern Japan. Which meant we already knew in March that it was going to be a really hot summer. How would you like to be in Georgia with no air conditioning? That's what all our friends in Tokyo were going to experience. And we knew that the clients were going to turn to the architects and say, well, what do I do about my building, right? And we also knew that the architects didn't know anything because they were putting insulation in their floors, right? Okay, so we did a workshop. We spent a very intense couple of months developing a whole workbook, including a glossary and all that. And then we went over there and we taught people like Kazuo Sejima about the basic issues for conserving energy in buildings. And this is Kazuo Sejima. These two, Susan Ubalotti is a friend of mine who I teach with at Berkeley. Her husband and she, George Loizos, they own an energy consultancy that works with people like Frank Gehry and stuff. So they're a really, really high-level energy conservation organization. I'm not saying Frank Gehry saves a lot of energy, but if he wants to put a Monet in a glass building in Abu Dhabi, they're the ones that tell him how to pull that off without cooking the Monet, right? So they're really smart people. Now, Susan and I both had connections to Tulane. I was a student there, she first taught there. And one of the things we learned from Hurricane Katrina was when we got in touch with people at Tulane and said, we want to help. Do you know what they said? They said, we're too busy just trying to dig out. Can you wait? And when we waited, it got too late. And so we knew that we couldn't wait, that if we were going to make a difference, we had to go now. So we planned this workshop, we invited a bunch of people, we went over, and one of the reasons that I felt like this was going to be a great thing to do was I'd already been through a big earthquake in Japan. Remember Kobe? Kobe had a big earthquake. Oh, he moved. He's supposed to be down here. Kobe had a big earthquake in 1995, okay? Really interesting earthquake for those of you who are interested in earthquakes. The epicenter was below the city. So the buildings moved up and then came back down again, okay? This was City Hall in Kobe. That used to be a story. This is actually the building code's fault because there was a law that said that you had to have a really rigid base to transfer the stresses into the ground from above when the building was starting to move, but it got narrower at this level. And so as a result, when the building came down and then it came back, or when it went up and then it came back down, it pancaked in the same place in building after building after building. Now this was 5 in the morning, nobody died in this building. Aren't you glad to hear that? A lot of people died in Kobe, but not in this building, all right? So what happened? What happened was really exciting. This was my exciting moment. This was, Mark mentioned my first book. the 1990s were this amazing flourishing of structural design solutions in California, because we had the Northridge earthquake, and in Japan. And a whole bunch of new ways of doing things, like buckling-resistant braces and other sort of solutions, appeared at this time and have now become integrated. So I knew what was going to happen after Tohoku. My plan was that it was going to be really straightforward. There was a crisis, and everybody was going to go, hey, what went wrong? And they were going to do some critical study, and then they were going to figure out how to change course. And I was going to go to Japan, and I was going to see exciting new solutions. Because I got to tell you something, and Susan and George saw this in that first workshop too. Japan's highly competitive architectural community can do amazing things when they put their mind to it. They had this Apple store that they were going to have people redesign, and it was in Taipei, and I forget where else, Finland and stuff like that. And they had different teams, and the goal was to get to zero energy. And the first day, Susan and George go to me, ha, 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 this is not going to happen. And we figured out how to run the calculations with grad students who didn't sleep for 4 days. So the grad students would keep these computers running overnight, and every day we'd come in and say, okay, you're this close, now we're going to talk about things like lighting, right? And we'd move them forward, and 2 of these teams actually got to zero energy. Zero was the target. Susan and George were blown away. They would have hired anybody who was in that room at the end of this workshop, because what they did was amazing. So I thought, what we were going to see by now was stuff to excite the rest of the world. And why did I think we could be a part of it? So this is a part where I tell you a little bit about California, because California is, as it often is, a provocative alternative to the way other people live. So here's electricity demand in California, okay? And this is what happens. So oil shock, economic downturn. People go, I got this, I know what we can do. They put in building standards and new standards for refrigerators and stuff like that. And California's per capita electricity demand has been flat since the 1970s. Flat, flat, flat. Now, this is the United States, which, as many of my friends from the Lawrence Berkeley Labs points out, means that there's another place up here, okay? Because that's an average. Okay, this is Japan. And here's that burble in the 70s, and then you can see it taking off again, and this is the 90s, early 90s, 25 years ago. Japan's per capita electricity cost is higher than California's. That's fairly amazing. Most of you probably believed, and most Japanese believe, that Japan is an energy-conserving environment. Japan's manufacturing and transportation industries definitely are. We, who are responsible for all that electricity, we ain't, right? And you've kind of seen that. So how does this play out, just to kind of let you know? So here's Georgia, by the way. You are above Japan, okay, by about double at this period. Here's California down here, right? And if you want to know who the highliner is, it's Wyoming, right? Why is it Wyoming? Because it's an energy-producing state, right? Places like Texas and Wyoming consume more energy because their politicians are not trying to put the brakes on it, okay? And that's a very straightforward answer. But why are we so different? Not just because we're from California, okay? I mean, we like change, but it's not just because of that. So in 1964, we had a meltdown, or 1959, we had a meltdown, okay? We had a nuclear meltdown. We had another one, this is a really good one, Bodega Bay. If you fly into San Francisco and you're coming north, coming down the coast from the north side towards SFO, and you look out, you'll see this peninsula with a big hole. And they were going to build a nuclear power plant there. And they discovered in the 60s that there were fault lines. And a bunch of people got in boats, and they surrounded little tiny boats and kayaks and all this stuff. We are California. And they got around this peninsula, and they raised heck, and they prevented Bodega Bay from getting a nuclear power plant, okay? And so the energy companies gave up on that one. This one, I think, was just shut down because it was a kind of a test reactor. Humboldt Bay, here's another one. All of a sudden, there was an earthquake, and people went, oh, it has fault lines too. Maybe we don't want to have a nuclear power plant on fault lines. So they shut it down. This one's super interesting. This is in Sacramento, which is our capital. And what happened there is that people like you started a referendum to close down the nuclear power plants. And you can imagine they were told this was going to cost the community a lot of money. You're going to have to shut down the power plant. You're going to have alternate forms of energy. You sure you want to do this? And they said, yeah, we want to do it. So they shut it down. Economy went up. Childhood leukemia went down. Okay? So great example. There are books in Japanese about this one. We had 2 nuclear power plants on the day that Fukushima Daiichi happened. Okay? One was immediately retired. The state of California said, we don't want what's going on there. The second one, they decided to retire at the end of last year, and it's going to take 6 years to do it. So we've actually gone ahead and shut a bunch of our nuclear power plants. And what does that look like? It looks like work for you guys. It does. So spurs economic innovation. Efficiency-related jobs up 15%. Also, a lot of money for education. Less power plants. We didn't have to build new ones. 1/5 of the state's electricity needs are met by conservation. So our population's going up, but we're not building a lot of these new plants. Slash CO2, that helps you guys out so you can actually raise babies in a better environment. Research is a really interesting area, and I'm going to show you one example on research. But research is a part of what we as professionals should also be doing. And so we saved money for our state, for individuals. We created jobs for people. We advanced the profession. We have this kind of virtuous circle, right? You can't do this only with the market. But the performance standards can start to drive the market. And the performance standards also drive innovation. So that you start to get these 3 poles working together to create more exciting architecture. I know, I got to finish this up soon. Let me show you this. You've seen how we're spending it. Zero net energy buildings. We have 200 in California. You've recently built 3. And you could be designing those buildings. You know how, right? But you also need people to drive it. So the belief in California is that well-considered regulation drives innovation, benefits society, and our profession economically. And people say, are you sure? And the answer is, the numbers don't lie, okay? The GDP in California is higher than the rest of the country. Okay, I'm going to jump forward a little bit, and I'm not going to show you that workshop, but I want to talk about Kazuo Sejima again, because I think this is really important. So some of you have probably seen Kazuo Sejima's house from around the same time. This is the Plum Grove house. And it comes from that stuff that happened in Kobe. There was incredible excitement from the mid-90s on about new structural solutions. And so Sejima had a new idea. I'm going to build a house where the walls are the structure, and they're going to be made of steel, and they're only about 1/2 inch thick. And so here we go. Don't do this in your studios. Your professors won't believe you. But that's what the wall looks like. It's steel, right? 1/2 inch steel plate in small cells. The drawings show some rigid insulation. I've been on that site. I never saw it. One of the people in the office told me they drew it for El Croquis because El Croquis would not publish a drawing without insulation. I don't know if that's true or not, but I kind of believe it. And then gypsum wallboard, because that's required by the building codes, okay? So they glued the gypboard to the wall because it was required by the building codes. And this is what the section looks like. So the roof had roughly R3 insulation. The walls had, if it's really there, roughly R4. The floors have R6. It's upside down again for the same reasons I told you about with Ando. And then, Mark's unhappy I didn't have this written on here. There's an R1 paint that was developed for NASA, okay, that cost a lot of money that they painted on the outside of this building, okay? Now I'm going to say, one thing that makes me crazy is They could have loaded up that roof with insulation super easily, right? And really enhanced the thermal performance, and it wouldn't have changed the aesthetics of this building one bit. So there was one easy move, but you had to understand building performance to do it. And at this point in time, Sejima didn't understand it. Some of you might have been to this building, done around the same time, the 21st Century Museum in Kanazawa. And I've been there, 2 big planes of glass. And in fact, when I went there when the building was under construction, I took this picture. This is the detail of those big glass walls. So it's steel, no thermal breaks, 2 panes of glass laminated, and then again, use heat to maintain comfort. So here we are on the site with that detail, right? Okay, so we understand. 2003, 2004, she's not thinking about it. Now, I really love students because you guys ask great questions. And you ask them of us, and you share them with us, and you make us think differently. So a guy who was a PhD student in Milan did a really cool thing. He started comparing Sejima's buildings in different countries over time. And this is what he discovered. He discovered that, so this is the building I just showed you. There's all the insulation. It's getting familiar, right? It's in the floor. It shouldn't be in the floor, it's in the floor. Don't do this, right? Somebody's gonna make it a test question this year anyway now. A little bit up there. Okay, then they get to Switzerland. Switzerland has energy codes. So they say, oh, we gotta put insulation in. And they've actually got triple glazing. There are some thermal bridges, because they're still trying to work it out. But they're working with local architects who are helping them figure it out. And then next building in Switzerland, now they're getting a little more insulation. France, they finally get it, man. Load up the roof, right? Lots of insulation in the roof really helps. But here's the thing, knowledge alone is not power. Remember what I said about the fact that you need that infrastructure of other people working with you. Mark and Saber and I went to this building last summer when it was just being finished up. It actually opened in October, Tsuruoka. This is the biggest building Sejima's done in Japan in a while, and it's a really beautiful building. But this is what the insulation looks like. It's there more for sound than it is for thermal reasons. You can see that there's no insulation there, but just notice how it's even been put in. This isn't a dumb contractor either. This is Takanaka Construction. This is one of the world's finest, well, I used to think one of the world's finest construction companies, but when it comes to insulation, maybe not so much, you know? You can see that they were just kind of jamming it in, and most of your professors have told you that if you just jam it in, it doesn't work very well. So you have a situation where you need those other people around. So in short, knowledge alone is not power. 4 more slides and I'm done. What about you, right? What about you here in Georgia? And the first answer is you still need to be educated. You need to know what you want to be able to do. You need to know what the good tricks other people have are and how you can utilize them. So, here's from your classes, right? This is the building physics modeling class from last fall. Some of you took this, Architecture 6242, right? Okay, there you are, you're doing that part, that's great. Another one is to find ways to express thoughtful leadership, which seems to be something you guys are actually working on. These are you guys, right? Jeffrey Collins and Soline Karim. I don't know who they are, I don't know if they're here today, but if they aren't, you can tell them I called them out. And you need to do that because you need to be at the table. Remember, the politicians and the business people are at the table, but the architects who are leaders in Japan were not invited to the table and have not been able to fight their way in. So they're not influencing decisions and discourse. And that leads to the last one. I thought this is the way it works. That's not how it works, okay? You and I all know that climate change is going to change our profession. And if you wait, other people are going to decide what that looks like. So what you have to do is you have to start thinking now about what it is your contribution is going to be. You have to set the table now. The reason the guys were so successful after the Kobe earthquake is structural engineers and steel manufacturers and concrete companies had been talking about better solutions. They'd done the research, they knew what the answers were, they just couldn't get people to put it in the codes. Then a bunch of people died, and all of a sudden everybody wanted to talk about what to do. There's going to come a moment where people want to ask you what to do. You have to be at the table and know what you want to say. That's really important, because if you wait, you're going to be like Susan and I after Katrina. Hi, can we help? Oh, please wait. Dial tone. No answer, right? Okay. I think it's great this is Martin Luther King weekend. There's been a lot of change. You're young. You don't know how much change there's been. I said I went to school at Tulane. I went to school in New Orleans. I can remember when I went to school, I was 18 at the time, so it was 40 years ago. And I went to school, and there were restaurants with little windows. And people who were African American could not order food inside the restaurants. They had to go to the little windows. Think about how much we've changed. It's not that there's not racism, but the opportunities have grown. And if we can change those things, and we can change sexism, then we can change this. And the people who change it are not going to be old farts like me. It's going to be you guys. Thank you. Yeah.
When I was in Tokyo with a friend, architect, I was looking at a house under construction, and it was a slab on grade, about a knee wall, about 18 inches tall, perfect concrete, embedded screws, threaded screws, sticking up about a foot. The lumber that's getting shipped to the site was about a 6x6 or an 8x8 solid
Sleepers,
timber,
yeah.
not blue lamp.
Yeah.
And they come to the site via a truck. They're all manufactured off-site, perfectly detailed,
Yep.
and put together like a trade show exhibit.
Yep.
Dropped onto those 12-inch long
Yep.
and screwed down.
Beauty, right? Beauty.
Yeah. So
Yep.
they've got a system that's so different than we have here, in terms of carpenters doing this stuff on site,
Yep.
on the fly.
Yep.
This thing is like a machine.
Yep.
So what's the deal?
What's the deal in terms of how do we change it, or what's the deal in terms of?
The difference over there with the residential construction and here, and then why don't they have some of the other things in place when they've got the systems much differently? We've been struggling here with off-site construction. Nobody's figured it out, even for little pods of hotels.
So I do a lot of stuff on prefab. Prefab is only about 15 to 18%. So what he asked about, he saw a building where there were prefabricated building components that were coming to this little residential house. Beautiful pieces of wood, probably somewhat wasteful because they weren't glue laminated, they were dimensioned lumber, and they were pretty big. But he was impressed that they were bringing these to the site. Prefab accounts for somewhere around 15 to 18% of the construction industry in Japan. If you went back and looked at that house, you might not find it very exciting because people think of houses as commodities. I've actually got a slide. Let me pull it up real quick just to give you a sense of this. You can see I'm all ready for a lot of questions here. All right, up. There we go. So, Japan, buildings are commodities. They last 25 to 30 years, houses especially. And so as a result, people think of them like cars. So they're less concerned about aesthetics and about fine-tuning them for their own needs, and they're much more interested in production. And so what that meant is that in Japan, and this is actual numbers, not per capita numbers, during this period from 1992 to 2014, half the years, they built more houses, single-family houses in Japan than they built in all of the United States. And we had 3 times the population, okay? So now you've got a very developed industry, and it doesn't have the challenges to prefabrication that we have, because it doesn't have the aesthetic issues about customization and visual appearance and that kind of thing. And so as a result, what you can do is you can fine-tune production. In actual fact, the prefab industry is having a lot of problems. And if you want, I'd be happy to send you a chapter that I have on that.
Yeah, my cousin had a house, and he had it for 30 years. He leveled the entire house, and they brought the kit of parts in there, and everything just fit perfectly.
Yep.
I mean, the joint lines were like a product, like
Yep.
an Apple like an Apple computer.
So I gave a lecture in Sendai, this is probably 15 years ago. And you know, when you're a foreigner in a country, a lot of times people ask you to go and talk about your own country. So I was on a Fulbright. They asked me to go and talk to a bunch of old guys up in Sendai who were studying English. And I thought, old guys are not interested in most of the stuff I research. So what I'm going to do is I'm going to talk to them about resale on residential property and return on investment. And when I explained to them that at the end of our use of a house, we sell it and somebody else buys it, and you might even do things like put a new door on to raise the price, all these old guys went, ooh, because each one of them was looking at the moment where they were going to have to tear down a house they'd lived in just to sell the land, because the house is actually a liability, right? And there's no return. They don't make any money off of it. And I'm like, here's my house. I earned more money in the California real estate market than I earned from the state of California as a professor, right? And they were like, I can't believe this. So there are a lot of big differences in the housing market. And a lot of you guys might be really excited about the funny houses you see, like the ones I showed you. But they're being built in a very different kind of an economic context and with very different kinds of pressures and expectations. Let's get a question from a student. Any students have questions? Please have questions. A bunch of them fled, but the grad students stayed, right? Yeah.
Hi.
Hi.
I'm Adriana, and I'm interested in knowing if in your research, or maybe with your students, you guys have looked into systems of generating electricity from more renewable methods. In other words, like, can a building consume the energy from waste that it produces? I'm wondering if...
There's a lot of interest in this in Japan, but what most people will say, and I'm going to show you a slide in a minute that kind of backs that up, is the first thing you want to do is you want to reduce the amount of energy you demand, and then the next thing you want to do is you want to create renewables. And so one of the first things you have, like, imagine you buy a 67 Chevy, okay? Pre-oil shock, big boat, made of steel, land yacht, right? Even if you try and put an engine in it that's electric, the thing isn't going to function as well. It's too big, it's too heavy. You try and take it on the highway and you're kind of going, right? Okay, so you want to think about that. There's a lot of subsidies in Japan to do that. This is a zero energy building that's done by Taisei Corporation. It's one of the innovative examples I was looking at. Now, I had a kind of a secret weapon. I had a back on my phone made by Fleur that allowed me to take infrared photos. And so when the guy walked me around and showed me this building, I said, can I take a picture? And he thought it was going to look like that, but I took that, okay? It's 123 Fahrenheit on the back of this thin film solar windows, okay? These are supposed to be creating energy, but they also create a lot of heat because they're very inefficient. This is in November, okay? So it was really hot. He freaked out. He was trying to get me to delete the photo. I wasn't going to delete that photo. I thought it was a great photo. Here's the actual way that solar wall is designed, okay? You can see how they're bringing the electricity off. And he also showed me this model, which demonstrates, again, no thermal breaks, right? For years, I bugged this guy to answer me, why didn't they put thermal breaks in this window? Okay, every single time I talked to him, I talked to his boss, I'd say, did you not know? I was walking around saying this to a bunch of people. Mr. Yagi here is from YKK. He and I are fighting the same battle on this. He wants Japan to have better windows too, because he can sell them to them and make a profit, okay? And I'm really good with that, because if he makes a profit, then you're not spending money on the electricity. It's like your insulated cup, okay? So right now in Japan, you're seeing a lot more of that. And so the thinking is more this, okay? That you're putting in a lot of high energy advanced technology, and all those solar panels and thin film and all that stuff takes a lot of electricity to produce, so you have a high embodied energy. And what we do, our piece, is not getting a lot of attention, okay? And what we do in California looks more like this. It's not that we're opposed to the cool stuff. We like cool stuff. We all like toys. We're the center of the tech industry, right? But we start with this, okay? Make our buildings more efficient. Then put the bells and whistles on, and we're all good, right? Okay. One more question. You guys got to have dinner and stuff, and we're going to go to Mark's opening, right? Which is supposed to happen in 2 minutes. So, one more question? No, it's got to come from a student. Come on, you guys. Don't you ask questions? You're as bad as my students. Come on. How about you in the rainbow? You got a question? Yeah, you. Yeah.
I always have questions. I was really taken with your talking about the nuclear industry. And the differences in California and the rest of the United States are particularly marked. We're still building Vogtle.
Maybe you'll never open it.
You never know. You really never know. But how do you see the rest of the United States being able to follow that California model of decommissioning plants?
So we have 2 really exciting, what do they call it, killer apps. So one of our killer apps is we have, as part of our building code, a requirement that you have to upgrade our Title 24 energy performance laws every 3 years. So when Arnold Schwarzenegger was governor, he's like Trump, right? He didn't want to do it, so it goes up like that much, right? And then now he just retired, Jerry Brown, right? The old Governor Moonbeam. And what he did is he said, oh, pwing, I'm going to really take this up. He was incredibly demanding on the architects, but he's created a lot of innovation, a lot of new opportunity. So one thing is, when you have the opportunity to influence performance statistics or performance regulations, you want to look for ways to automatically ratchet it up. That's a really big one. The other way, which is going to take more time, but I think is really important for your community, is we're kind of a crazy democracy. I don't know if you heard last year, it wasn't on the ballot, but they tried to put on a thing on the ballot that we would split the state up into 3. And this guy got enough signatures, so it was supposed to be on the ballot, but the Supreme Court said, we already had that conversation and got rid of it, because in 2016 we had something on the ballot where some guy wanted to break it up into 7, okay? Now, how do you end up with something so weird on the ballot? And we get a lot of other stuff like that. It's a very aggressive democracy in California. Anybody who gets a bunch of signatures can propose a law, and it's on the ballot, and all the citizens vote on it. And many of the things that we do that started the whole building energy issues came about because citizens were very much involved in making those changes. Now, I know, because I gave money to Stacey Abrams, that around here, it's been a little bit harder to have what looks like a really robust democracy. But I think working towards that and making sure that you have the ear of people who are in leadership, in business leadership and in political leadership, is hugely important. So, a lot of times architects, we get locked in our own little language and our own little place, right? How many of you even know anybody in the political science department or the business school? Good, you do, that's great. But most of you don't, right? You're not going to have their ear if you don't get to know them now. So one of the things you want to do is you want to figure out ways that you can actually influence people who can make change. And that was something I had a lot of interesting conversations with architects about right after the nuclear power plants. Because I would go, and I'm kind of naive, and I'd say, well, we've never really talked about this before, but how do you influence your politicians? And they'd go influence my politicians? I don't influence my politicians. And I'd say, well, do you go talk to them? And some of these guys are the heads of big corporations and stuff, and they'd say, no, I don't talk to them, right? And they have very limited voice in really important areas where we can make a big difference. So I think those are the things that you guys need to be working on. And if you do that, When these things start to percolate up, as people are like, oh, you know, Georgia's really having a lot of economic damage, and you are already, because of climate change, then you can say, we can be part of the solution. We got this. We really know how to do this, you know, like insulating buildings, it's like brushing our teeth, right? So it's that easy. Now let's go see Mark's show, huh? Thank you very much.